Now let's do the calculation in figure 20-11C. Now notice sizing the primary overcurrent device based upon the third level of current less than 2 amps. Step 1, we take the kVA times 1,000 divided by the voltage. So we'd have 0.8 kVA times 1,000 to get it into volt amps. Divided by 480, we come up with a full load amps of 1.7 amps. Now, not being too simple, but yes, that's less than 2 amps. So we know in the step 3 from table 450.3b, we're going to select the 300%. So 300% of 1.7 is 5.1. Again, 5.1 is falls in that range of 5.4 less. So we are rounding it down to a 3 amp because you can't round up, see, in accordance with our table 450.3b, no note 1 listed beside that percentage. So table 240.6a, we round down below 5.1 to a 3 amp overcurrent protected device, and that is what our solution is telling us. Now you'd say, well, you know, once we have this control transformer and we have maybe 2 or 3 other contactors on it, and we're getting or maybe we're just getting an unusual inrush current, and we want to apply the step 1 and the maximum size that we'd want to be using from 430.724. So the step 1, 1.7 full load amps, times the 500% now selected from 430.72C4, we come up with 8.5, see. Now, 8.5, we've rounded it down to a 6 amp fuse selected from 240.6A based upon 8.5. Now that could be a fuse or a circuit breaker if you could purchase in the 6 amp range. So the solution, 6 amp overcurrent protection device in the primary side, and we note here that the secondary side is a motor control circuit. So we know then that it's either a class 1, 2, or 3 that we'd be using, and in that range that we see there, more than likely we're going to be dealing with a class 2 or class 3 circuit. But we've given you those sections. A class 1 circuit, you can get those outputs in 725.41A for a power limited, and that's 1,000 volt amps or less, and we'd be at 30 volts or less. If it's a unpower limited, well, God, you know, usually we're looking at 480 control, 240, 208, 120, depending on the voltage. OSHA kind of likes that 120 volt control or less. And then, of course, you get into a class 2 circuit, then those, you know, can operate at 30 volts or less. And we know that NFPA 70E in the Article 100 says, you know, those usually are not a dangerous shock hazard or a arcing hazard to the user at all. But the class 3 could be. So 70E says you've got to evaluate those and make sure that the class 3 circuit is not a shock hazard or arcing hazard that could burn you beyond a second degree burn, 1.2 calories per centimeter squared. Now we can get these outputs of a class 2 and 3 looking at our table 11A, I believe, for AC and 11B for DC. And you can get a good feel for these outputs that a class 2 or 3 would put out, but they're defined in 725.3 in the NEC. And that's what this figure 20.11C is illustrating, is when that primary is less than 2 amps and we're applying either table 450.3b at 300% or up to 500% in accordance with 430.72C4, and that's what our figure 20-11C is illustrating to the designer or the installer using the code.